Hello and welcome to this required practical video for the AQA exam board, all about waves. So this is our vibration generator. It's very important that you read the instructions carefully because this one has a maximum current of 1 amp. So on our power pack we've limited it so no one can accidentally turn it up too high and damage our vibration generator. Instead of using a signal generator, these use the power pack to provide the signal to cause the vibration. So the frequency of the vibrations is going to be exactly the same as the frequency of our power supply. So in a moment I'll go through and talk briefly about how to use the vibration generators because it's something that I had to learn when this required practical came out. I've never used one before. And then I'll show how I set up this experiment, which I'm going to pan out for to show you the whole thing. And there we go. So I've got my string attached to my vibration generator. I've got a meter stick so I can measure the waves that are produced on the string, and then I've got my pulley and my mass. Now that involves a little bit of fiddling around, trying different masses and moving this bridge different distances to get the best possible number of waves that you can for measurement. The longer your piece of string, the more waves you're going to be able to measure, but in order to be able to get this on the camera screen I've had to settle for only being able to see one complete wave. But the more you can fit on, the better your measurements will be. So that's the setup. I'm going to quickly slot this in behind my string, so hopefully you'll be able to see it a little better. Da-da-da. Now I can't reach my power pack. This is good planning, isn't it? So there we go. So hopefully now we'll be able to see the string really, really well. Here we've got our string, and with a tiny piece of adjustment. Come on, play the game. There we go. You can see that we've got a wave that doesn't look like it's moving. We've got peaks over here, little node in the middle, and then some more peaks over here. So we should be able to measure the length of these waves. Now, unfortunately, with only one hand, it was much better a moment ago. Ooh, there we go. Adjustment of the bridge, and you sometimes get a much better result. You can either adjust the tension in the string, so if I just quickly either slacken or tighten the string just by pulling on it, you'll see it adjust the wave. Now the more time you can spend, oh, now my bridge is falling over, this is no good, is it? This is no good. You can get a much more obvious wave. Oh, there we go, that was good, and now I lost it again. I'm going to have to re-record this, aren't I? That'll do me, that'll do me, that'll do. So, now we are going to measure the length of these waves here. So we're going to measure a half wave from here to here. And I'm going to use my meter stick to do that. And then I'll briefly go over the calculations you need to do. Okay, so here's a really terribly drawn picture of a vibrating string. So the first thing I'm going to show you is that each of these points here are called nodes, where it looks like there's no crest or trough. They're called nodes, and they indicate the points that are half wavelengths. Come on video, focus. There we go. So this has 1, 2, 3, 4, 5, 6, 7, 8 half wavelengths. Okay, so if we measure the entire length of our string, and I'm going to say that it is 2 meters in length, and we have 8 half wavelengths along it, the way we are going to work out our full wavelength is to count up our 8 half wavelengths, or however many you counted, however many of those nodes that you saw on your string, and we're going to divide it using our overall length. So I'm going to do 2 divided by 8, which is going to give me 0.25. So 0.25 meters is half of a wavelength. So to turn it into a full wavelength, we're going to times it by 2. So my wavelength in the equation is going to be 0.5 meters. So using our wave equation, which is V is equal to F times lambda, where V is the velocity of the wave, F is the frequency, and lambda is the wavelength. The frequency of our supply in the UK is 50 Hertz, and I now have a wavelength of 0.5. So to find the speed of the wave, I'm going to do 50 times 0.5, which is going to be 25 meters per second. There we go. Hey, if you're new to one of these and have never used one before, just like I was until a couple of days ago, you have to plug your vibration generator into an AC power supply. Now on this particular model, it's designed with some safety features to protect the membrane inside, because whenever you're attaching or removing accessories from the vibrating part here, you risk damaging the membrane. So it's got this unlock and lock feature. So when you are attaching or detaching anything, make sure you lock it so that that isn't going to move back and forward and damage your membrane. And then when you actually want to start your experiment, unlock it before you turn on your power pack. So that's the kind of basics there. So for this particular one, this one has a little attachment where you feed your string through the hole and then tighten the screw on top, and it just pops in like that. And then when you're ready, you just unlock it and turn on your power pack, and off it'll go. The fiddly bit is adjusting your bridge and your masses to get a really nice long wave. With mine, so it fitted on the screen, I had to keep it quite short, so it wasn't ideal. But the longer you can make it, the better.